Okay, so this equation says to use nodal analysis to derive a system of two equations with two unknowns at the node voltages V1 and V2, and you don't have to solve the equations. So the way node voltage works is first you identify your nodes. Well, here they're identified for us, so we don't have to identify them. Except you do have to label a ground node. And usually, if you don't have any other reason to choose something, the ground node a lot of times is just going to be at the bottom of the circuit. The next thing that you want to do is you want to label any voltages that you know what they are. Now remember, to know a voltage means you know what it is relative to ground. So even though we have this 5-volt voltage source up here, we don't know what the voltages are relative to ground. We know that V1 is 5 less than V2. The negative side is going to be however it's labeled. However it's labeled will be that much less than the positive side. But we don't know what it is relative to ground. However, we do know what the voltages are at these top two corners relative to ground. So if I look at the right hand side, I see that the other side of this voltage source has to be 2 less than the bottom, because that's the way it's oriented. I've got the minus sign on top, and so the top side is 2 less than the bottom side. So that means that my voltage right here, if I call ground 0, the voltage at the top right here is -2. Similarly, on this side, the top has to be 4 more than the bottom, so the voltage right there is 4. So that's the first thing you want to do, is figure out whatever voltages you can label relative to whatever you decide to make ground. Then you want to look at each node, and you want to look at the currents coming out of that node. So you want to look at every direction coming out of that node. And here we see, when we draw that, we notice that between V1 and V2, all there is a voltage source. When we see that, that lets us know that we can treat this as a supernode. And what that means is we're going to write all of the currents coming out of both of them in one equation, and then we'll write another equation showing the relationship between V1 and V2. As a matter of fact, let's write that equation first. I know that V1 equals V2, well, let me write it another way. I would say the positive side minus the negative side So the positive side minus the negative side equals 5. So V2 minus V1 equals 5. Now, coming out of a node, you're going to sum up, what we're going to do is we're going to sum up all the currents coming out of a node. The sum of all the currents will equal 0. And here's how you write a current. So Ohm's law tells us that V equals IR. Well, it's not really V. That's confusing because V might stand for an absolute voltage, but what V means is on our given resistor that we're talking about, we have a current and it's going in some direction that we have labeled. So it doesn't matter what direction it is, it's just we choose a direction. And there's a voltage difference across that resistor. So if I call this side VA and this side VB, then what this V really refers to is VA minus VB. It's the voltage on the side the current is coming from minus the voltage on the side after it's gone through the resistor. That's what this voltage is. And so the current, if I solve for current, the current equals V over R, or I would say this is VA minus VB over R, and VA is the voltage where the current is coming from, and VB is the voltage on the other side of the resistor. So when I start with my supernode up here, I'll start with V1, and I'll go to the left. And I'll get V1, that's the voltage where I'm starting, minus the voltage on the other side of the resistor is minus 4, over the resistance is 1. So that's our first current. Our second current, we're going to go down, and that'll be V1 minus our voltage on the other side. The other side is ground, so that's 0 over 2. Now, I don't do anything for this middle branch because I turned this into a supernode. So I skip this current right here, and I go over to V2. And then I'll do V2 going to the right. So I'm starting at V2, minus the voltage on the other side, so minus a negative 2 over 2, plus the voltage, the current going down will be V2 minus 0 over 1, and those all add up to 0. If you watch, I very cleverly, in the next section that's coming up, misread my messy handwriting as read this 1 right here as a 2, and I write it as a 2, and then some calculations I do after that are wrong, and then I make another mistake and it's wrong as well, and then I make another mistake and it's also wrong. But the main part of this problem was to get this equation. Actually, that was the problem, was to get this equation. So any of the calculations after this don't really matter. I do catch the mistakes eventually, but I did want to alert you to that. So let me simplify this. So this is V1 minus 4 over 2 plus V1 over 2 plus V2 plus 2 over 2 plus V2 over 1 equals 0. I'll multiply through by 2, and it gets V1 minus 4 plus V1 plus V2 plus 2 plus 2V1 equals 0, or V1 plus V1 plus 2V1 is 4V1 plus V2 minus 2 plus 2 is minus 2. I take it to the other side and I get 2. Although it looks like you didn't have to do that. You could have just left it like this. And then our other equation is minus V1 plus V2 equals 5. And then you could solve these, but it says you don't have to. So let me make sure I have everything right. Plus V1 over 2, V2 plus 2 over 2, V2 over 1. As long as I didn't make a mistake here. Yeah, I did make a mistake. Look at that. That's 2V2. So it changes this. So that's 2V1 plus 3V2 equals 2. Does anybody see any other mistakes? I'm very good at making them. Alright, any questions on this one?
Can you explain how you made the middle branch the supernode again?
Sure. Okay. Alright, so when I'm doing a node voltage equation, okay, so let's say this was the circuit that I was looking at, and I was trying to do nodal analysis on it. Well, first I'd identify my nodes. So actually, I'm going to change this a bit. Okay, so I'll identify my nodes. So I have a node here, V1, V2, V3. I could make that a node, but I'm not going to, because when I do this, I'm probably just going to combine these two resistors because they're in parallel, and V4, and then I would make this ground. Okay, so then if I had some voltages here, I might label them, like I would know what V4 was, for instance. If this was given to be 10 volts, I would know that V4 was 10. So I would actually already have that voltage. But then when I look at my others, so I look at my my nodes, and I look at the currents coming out of them. So like for this node right here, I have a current here, and I have a current here, and that's, well, this one, okay, I'm going to change this because I'm just making it up and made it have a super node, so I don't want that. So I no longer have a node at the bottom other than the ground node. Okay, so okay, so now the bottom is all ground. So V1, V2, V3. So coming out of V3, I have a current here, and a current here. Coming out of V2, I have a current here, a current here, a current here. Coming out of V1, current here, current here, current here. But then I look at between V2 and V1, and I see the only thing that I've got there is a voltage source. So when that's the case, I treat both nodes together as a supernode. And then when I do the currents, I'm only going to do the current, the currents I'm going to write are the current here, the current here, the current here, and the current here. I don't do the current between the two nodes because I'm treating these two nodes together. So I don't do that. And so what I'll have is I'll have four equations. So I would have V2 minus V3 over R1 plus V2 over R2 plus V1 over R3 plus V1 over R4 equals 0. And so I get that equation, and those are my four currents that are coming out of these nodes, plus I get my equation that relates V2 and V1, and that equation is I take the voltage on the plus side, V2, minus the voltage on the minus side, V1, and that's going to equal whatever this voltage is, Vs. And that's how I set up the equation for my supernode. And then V3, I just deal with it by itself. Does that answer that question?
Yes,
Yes,
it
it
does.
does.
Thank you.
Okay, you're welcome. Any other questions? Okay, so going back and looking specifically at this problem, I had my currents were V1, so my currents were this current, this current, this current, and this current. So V1 minus 4, that should have been over 1, right? That should have been over 1. V1 minus, yeah, see how many mistakes I made? So V1 minus 4 over 1 for that one. And so that would have changed this to a 2 and this to an 8, and so who knows what this would be. How did I not catch that when I tried to check my answer? Okay, so that'd be V1 minus 4 over 1, and then V1 over 2. Oh, I see what it was. I misread my handwriting right here. That was supposed to be a 1. And then V2 over 1 is this one. And V2 minus negative 2 over 2 for this one. And so that's this equation. And then my other equation is I take the voltage on the plus side, which is V2, minus the voltage on the minus side, which is V1. And that's going to equal the voltage as labeled on the voltage source.